Theivanai Ammal College for Women. Learn, live, and lead.
Hello students, I am Bharathi, Assistant Professor, Department of Mathematics, Theivanai Ammal College for Women, Villupuram. In today's class, we are going to learn about integer linear programming. Integer linear programming are the linear programs that are restricted to integer values. In that, we are going to learn about branch and bound algorithms. For example, maximize z is equal to 5x1 plus 4x2 subject to the constraints x1 plus x2 less than or equal to 5, 10x1 plus 6x2 less than or equal to 45, and x1 and x2 are the variables that should be in non-negative integer. For this, we are using graphical method. In graphical method, we are finding feasible region. In that, for the first constraint, we have to put x1 equal to 0. We get x2 equal to 5. That is 0, 5 as a first point. In the same way, we are going to put x2 equal to 0. Then we get x1 equal to 5. For this first constraint, we have to plot 5, 0 and 0, 5. This is the first constraint we have found. In the same way, for second constraint, that is 10x1 plus 6x2 less than or equal to 45. Here we put x1 equal to 0, we get x2 equal to 45 by 6, that is 7.5. Here 7.5. 0, 7.5. In the same way, we are putting x2 equal to 0. Then we are having 4.5, 0 here. Now we have found the feasibility region. Here for the first constraint, we are having x1 plus x2 less than or equal to 5. Therefore, for the first constraint, we have the feasibility region here. And second constraint also, we have 10x1 plus 6x2 less than or equal to 45. So we have the feasibility region, and we are naming it as LP not space. And we are finding the optimum solution for this LP not space. LP not space, we are finding that in the feasibility region, where are the intersecting points occurs, that point should be substituted in the maximization function. For example, 0, 5 and this value 4, 0, name it as A, B, and this should be, this is have to find. For this, we are solving the two constraints. We are solving these two constraints means we have point x1 equal to 3.75, x2 equal to 1.25, and we are having z is equal to 23.75. This is the usual graphical solution. In our ILP problems, we have to find integer values, so that we move on to the branch and bound algorithm that we called as BNB algorithm. So that x1 and x2, we are choosing x1 first. If we are choosing x1 as 3.75, we can write it as 3 less than or equal to x1 less than or equal to 4. In the same way, the LP not space can be split into two spaces now. That is, that x1 should be in 3 or either 4. So we are having this two branch, that is LP1 and LP2. If we are having one more constraint, in the given equation. That is, we have the constraint already x1, x2 less than or equal to 5, 10x1 plus 6x2 less than or equal to 45. Now we are having one more LP1 space. In that we are having x1 less than or equal to 3. So we have to find the feasibility range that x1 is equal to 3 means x1 less than or equal to 3. For LP2 space we have x1 greater than or equal to 4. This is for LP1 space and this is for LP2 space. In LP2 space we have same constraint, first two constraints. And third constraint is x1 is greater than or equal to 4. In that we are substituting x1 is equal to 3 in this region. Now we are considering LP1 space is this alone. Now we are leaving this feasible region because of the restricted condition that we are having. We have to find only the integer values for x1 and x2. Okay, then we are substituting again the feasible values. That is, already we found this point. Now we are finding again and again these points. Now we are finding x1 equal to 3 and we are substituting x1 equal to 3 in the first constraint, x1 plus x2 less than or equal to 5. If we are substituting x1 plus x2 equal to 5, we are having x1 as 3 plus x2 equal to 5. Now we get x2 is 2. Then we will apply x1 as 3 and x2 as 2. Z is equal to 5x1 plus 4x2. We are having x1 equal to 3 and x2 equal to 2. That is 5 into 3 plus 4 into 2. We have 15 plus 8. Z is equal to 23. For LP1 space, we obtain the optimum solution. That is x1 equal to 3 and x2 equal to 2. Z is equal to 23. We have the integer values. So we attain lower bound and optimum solution. Let's move on to LP2 space. For this we are having x1 equal to 4. That is, we chose the condition like that. For x1 equal to 4, we have to apply in the second constraint. Now we are considering this space as LP1 space. LP naught space has split into LP1 space and this is LP2 space. For LP2 space, we chose x1 equal to 4 and we have to find x2. For x2, we have to apply this in second constraint. 10x1 plus 6x2 equal to 45. x1 is equal to 4 plus 6x2 is equal to 45. We have x2 is equal to 0.83. x1 is equal to 4 is the integer value and again we are getting x2 equal to decimal value. If we are substituting these values in our maximization function, we obtain 23.33 is a decimal value. So we have to proceed further. For this we are choosing now as x2 value because it is a decimal value. If we are choosing x2, we are having range now as 0 less than or equal to x2 less than or equal to 1. In this LP2 space, we have split into again two branches, that is LP3 and LP4. For LP3 we choosing x2 equal to 0. LP2 is in LP3 space x2 equal to 0 means we have to substitute in this area, then we obtain x1 is equal to 4.5. In this LP2 space we are moving to LP3 and LP4 space, that is this line. x2 if we are substituting x2 equal to 0, we have x1 equal to 4.5, z is equal to 22.5. If we are moving to x2 is greater than or equal to 0, we don't have any feasibility here. Now we are discussing about this x-axis, x1 axis alone. So we don't have feasible solution in LP4 space. So we conclude here is no feasible solution. We move on to LP3 space. In LP3 space we are having x1 again as 4.3 as a decimal value. Now we again consider x1 is having limit 4 to 5. Okay, we are having this line is a feasibility range. If now we are choosing x1 equal to 4 and x1 another point is x1 equal to 5. In our LP3 space we have this point alone. If we are choosing x1 equal to 4 and x2 equal to, if we are putting x1 equal to 4 means we have x2 equal to 0. Then these values we are going to substitute in maximization function means we have z is equal to 20 and we occur lower bound, that is optimum solution. In the same way x1 greater than or equal to 5 means that is out of the feasibility area. So we conclude there is no feasible solution for LP6 space. This is all for this today's class. We'll see you later.